We call these numbers, numbers 1 to 9, non-zero numbers. Non-zero numbers because they're not zeros. So anytime you see the values 1 through 9, they're significant. Any zeros between them are also significant. There are 4 significant digits. $300,432. Two leading zeros are not significant. So this is any zeros before the numbers 1 through 9. So it doesn't matter which column they're in, but if you have zeros before a number 1 through 9, they don't count. They're called leading because they come in front. So an example could be 0.0093. These 3 zeros come before the 9, so they're not significant. Those are leading zeros. So how many significant digits then in this question if these 3 zeros don't count? 2. Right, 1 to 9, because then that's got a 0. Yeah. So 3 trailing zeros only count if there's a decimal place. So trailing zeros, so these are at the end of your values, only count if there's a decimal place. So 120. 120. That is a trailing zero because it comes at the end. Is there a decimal place here? No. So that does not count, that 0, as significant. So how many significant digits? So that only has 2. You don't forget about it because it's the difference between 12 and 120. If somebody owes you $120, you're not going to accept 12 as payment, right? So don't change the value, but only the 1 and the 2 are significant. How about 120.0? So now we've got 2 trailing zeros. How many? It says trailing zeros only count if there's a decimal. Is there a decimal? So then they all count. They all count. It's not just the one in front of the decimal, it's the one after the decimal as well. So if there's a decimal anywhere in your number, the zeros will count. So how many significant digits here? 4. Yep.
Because who watching?
I don't know, can you? 120,000. 120,000.
There's only two.
Ask yourself, Haley, is there a decimal? No. No decimal. Are those leading or trailing? So they're trailing, so you're going to look at this one. Trailing zeros only count if there's a decimal. Two significant digits. Okay? All right. Scientific notation. We're going to deal with some very large numbers in this unit. Notation. A real number, like a regular number as you're used to seeing it, is called standard notation. Yep. So, Aaliyah, give me a big number.
35,000?
35,000? 35,000. Do we want a decimal place or no decimal place? It's up to you. You want to put a decimal in? Do we want another zero or just leave it like that?
Zero.
You want another zero, okay. All right, so we've got this standard notation, regular way of writing it. Scientific notation uses the significant digits and the times 10 to the exponent. That times 10 represents every place that you move your decimal. When we write in scientific notation, only one significant digit can go in front of our number. So we would change 35,000 to be 3.5. How many significant digits does it currently have? No, it's not 2, because there's a decimal. So all those trailing zeros count. So this exponent will be how many places we move the decimal place. So you move it from between the last two zeros to between the 3 and the 5. So 1, 2, 3, 4. Because this is a number larger than 1, the exponent is positive. So your exponent will be positive if this regular number here is greater than 1 because we moved it to the left.
Would that say one exponent?
If your value is greater than 1, if this number here is larger than 1, your exponent will always be positive. And the number for your exponent will be how many spots you move the decimal place. Do you see where it started? started here,
Yep.
you have to move it so that it's between the first and the second. So 1, 2, 3, 4 spots, so it's gonna be times 10 to the 4. Yep,
If they were leading that, zeros with a decimal in front of them,
that's a, give me an example. Give me an example of a number with leading zeros.
like 0, 0, 0, 0, 6, 1, 6.
Okay, 0, decimal 0, 0, 0, 616. All right. How many significant digits in this question? There's only 3, because these are leading zeros and they don't count as significant. So we would have to put only one number in front of the decimal. You include all 3 significant digits. Then how many places did we move our decimal? 4. Because this number is less than 1, we moved our decimal place to the right. It is negative. So if this quantity here is less than 1, your exponent is negative. And we only keep the significant digits in scientific notation. So, put this number into scientific notation. Okay, put that number into scientific notation. There's no decimal. So what values are significant?
602.
The 6, the O, and the 2. Yep,
23.
it is to the 23. So the decimal was over here. We moved it 3, 6, 9, 12, 15, 18, 21, 22, 23 spots. Okay?
Wait, why is it 23? There's no decimal.
Wait, I got 21.
The number to be dropped is greater than or equal to 5 with numbers after it.
Greater than 5 with numbers
Round up. If the number to be dropped is greater than or equal to 5, and that 5 has numbers after it, round up. If the number to be dropped is less than or equal to 4, round down. You should all be familiar with these rules because you've done math before. So if you're dropping a number and the number's 5 or greater, round up. If the number to be dropped is less than 5, then you're rounding down. The difference here is if you have a 5 with nothing after it or a 5 with zeros after it. So if the number to be dropped is equal to 5, followed by zeros or nothing. So if the number to be dropped is 5, followed by zeros or nothing, round to nearest even number. We're going to do some examples. So these are the rules for, so if we are rounding to 2 decimals, the number that you're looking at is in the 3rd decimal place. So the first number to be dropped is underlined. You're rounding to 2 decimal places. So the number that you're looking to drop is the rule that you're going to be using. So the very first one, you're dropping the 5, there's numbers after it. So what do you do to the 5 in front of it? Round it up, leave it alone, round up. So try those and we'll double check our answers. 1 is 6.24 because the 3 is less than 5, so we just leave this one alone, round it down. This one, we're rounding to this, so we're looking at this number. So there's zeros after it, so we have to round this one to the nearest even. It will stay the same. Milos, we're taking these up. You got it?
Yeah.
Okay, so this one, we've got a 5 with nothing after it, so the previous number has to be, leave it alone, yeah. Yep. That's the nearest even number, 2. And then we're rounding to this position, so we're dropping the 5. It has numbers after it. So what happens to this 4? Doesn't round down. It goes up to 5. I don't know. Okay, say it louder.
182.77.
Get that? Awesome. All right, now, which one of these numbers has the least number of decimal places? The first one has none. So your final answer has to have none as well. So you can't have this because this is more accurate than that number. So you would have to round this number off, to only the 1 position, right? You can't be more accurate than ones. So if you round that off, it's 183. Final answer can't be more accurate than your least accurate number, which means you can't have more decimal places than the lowest number of decimal places in the numbers you're adding or subtracting.
So let's say the first.
6, 7, 7.
So round your answer to the same number of significant digits significant digits, short form.
And that says what, signal?
Significant. Round your answer to the same number of significant digits as the value with the least number in the question. All right, so Jaquel, give me a number.
407.
407. Kyla, give me another number. 53. I want you to calculate this in your calculator. 407 times 53. 21,571. Wow, this is going to be a big number. Okay. How many significant digits in 407? 3. How many significant digits in 53? Which one of those is the smallest number of significant digits? 3 or 2? 2. So our final answer can only have 2 significant digits. So when you multiply or divide, your final answer can only have the same number of significant digits as the lowest number of significant digits that you started with. So we can only have 2 in this number in our final answer. So we're going to round it. We can do 2 things. We can round it and then replace the numbers with zeros, so we have a placeholder, or we can put it in scientific notation. So, this number and this number we will have to keep. So we're dropping the 5. What is the 5 going to do to the 1? We're going to round it up. So our final answer will either be 22,000. See how I replace these 3 numbers with zeros? So I'm not changing my number from 22,000 to 22. Because that would be bad. Think about a paycheck, right? You don't want your employer to drop those zeros on you. Or we can put that in scientific notation. We move the decimal place 1, 2, 3, 4.